Alright, we're going to start chapter 5, and chapter 5 is all about triangles. And you're going to learn about the ins and outs of the triangles, probably more than you ever wanted to know. And part of it is that in order to do your favorite part, which happens to be proofs, once again, we have a lot of theorems. We've got some postulates that are going to help you be able to prove whether triangles are right, obtuse, acute, etc. Throughout this chapter. So let's go ahead and start our notes right here and start off by taking a look at what is considered an exterior angle in a triangle. So an exterior angle of a triangle, or sorry, interior angle, hopefully we realize this on the inside. So in this triangle right here, we've got 1, we've got 2, and I'm drawing lines to the 3 angles that would be considered interior. That is important because then we need to know what the exterior angle is, which happens to be the one that is on the outside. Okay, so don't forget, exterior is outside, interior right here is inside. Talk about more about this later. But when we do recognize the exterior angle, what I need you to end up doing is taking a side of the triangle and extending it out. Because remember, if I ever to add this interior angle right here and this exterior angle, hopefully you realize that that's a straight angle, and that means that it's going to be supplementary. So what I don't want you saying or doing is saying, all right, this is my interior angle. How about let's make this whole other side right here my exterior? That would be incorrect. All right. Let's go to the next term. The corollary to a theorem. That right there is a statement that can be proved easily using a theorem. Okay, so once again, we are doing quite a bit of proofs in this section, so it's going to be important to know all of your terms. So there's 2 ways for us to classify a triangle. Okay, the first one right here is classifying it by its sides. And so let's go over the 3. The first one is a scalene triangle. What does that mean? That no congruent sides. Okay, none of the sides in the triangle are congruent. The second one we have is an isosceles triangle, telling us that at least 2 sides of the triangles are congruent. Remember, if they're congruent, that means they are the same length. Next up, we have our equilateral triangle, and that tells us that 3 congruent sides. So all 3 sides are of equal length. So that's how we classify a triangle by its sides. We could also classify triangle by its angles. Okay? If it's an acute triangle, you've got 3 acute angles. If it's a right angle, you have 1 right angle. If the triangle is obtuse, then you have 1 obtuse angle. And if it's equiangular, then that means you have 3 congruent angles or 3 angles that are the same. Now, important to note, if the triangle is equiangular, it's also going to be equilateral. Okay, and vice versa. If the triangle is equilateral, the triangle will be equiangular. Because in order for all 3 sides to be the same, the interior angles must also be the same as well. Okay, so, and what do we call that? If it's equiangular and equilateral, we call that a regular polygon, or in this case, a regular triangle. All right, we got some theorems here. Okay, the first one, the sum of the interior angles of a triangle is equal to 180 degrees. So that is the triangle sum theorem. If it is a triangle, then the 3 interior angles add up to 180, no matter what. Otherwise, it's not a triangle. The exterior angle theorem, theorem 5.2. What this is saying is that this angle 1 that's on the outside, this exterior angle is equal to angle A and angle B. the two non-adjacent angles. So angle 1 is equal to the two non-adjacent. Remember, adjacent means next to. Angle C would be next to angle 1, so that can't be it. It's the two non-adjacent angles. Therefore, it says angle A plus angle B is equal to angle 1. So that right there, exterior angle theorem, is an important one to help you solve angles in certain scenarios. Corollary to the triangle sum theorem. The acute angles of a right triangle are complementary. Okay? Remember, in a right triangle, if one of the angles is 90, the other two angles, A and B, have to equal 90. Because remember, we have a triangle sum theorem. And in the triangle sum theorem, it states that the interior angles have to equal 180 degrees. So if angle C is 90, then the other two angles have to be 90. We don't know how big those other two angles are, but they do have to add up to 90 degrees. So we get our total of 180. So let's put it all together right here. Let's take a look at our extra practice. Okay, start off number 1. It says classify the triangle by its sides and by measuring its angles. All right. Now, if we were to measure it in real life, we would probably use a protractor. Okay, so we don't have that. If you were to see a problem like this, I'd say you'd be able to pretty much classify just by looking at it. Okay, so if I take a look at this right here, at number 1, this angle Q looks pretty obtuse, right? Greater than 90 degrees. So for number 1, let's go ahead and call this an obtuse. And it looks like none of the sides are the same, so that means it's obtuse scaling. All right, looking at number 2. If we're to best classify by measuring its angles, or what it looks like, this right here, angle C, I would say that this is a right triangle. If we had a protractor, we'd definitely be able to figure out that that's 90 degrees. Right now, we're just eyeballing it since we're not using a protractor. All right, so we said right, and if it is a right triangle, and look at all the different side lengths, they do not look the same. So we can go ahead and say that this is right scaling. All right, and then number 3. Things look a little bit different than 1 and 2. All right, looking at the angles, none of them look greater than 90, so we can go ahead and say these are acute. And if we were to classify it by its sides, this is isosceles. All right, so we got an acute isosceles triangle with number 3. Let's go ahead and move on to number 4. So we've got this problem right here. It says classify triangle ABC by its sides, then determine whether it's a right triangle. So now, what I would expect you to do is solve this problem mathematically without having to try and draw it out, because drawing will not always help us here, especially when we do not know, or if the points are not directly above or next to each other, vertically or horizontally. So what do we do then? Okay, if I want to classify a triangle by its sides, we need to know the length of it. Okay, so I need to use distance formula. So step 1, we'll go ahead and use distance formula, because that'll tell me how long the sides are. So I got to figure out, well, how long is side AB? Okay, so we use the distance formula right here to put that all together. I can go ahead and say 9 minus 6 quantity squared plus 3 minus 6 quantity squared. Alright, so I want you guys to go ahead and take a moment to simplify and solve these things out. 9 minus 6 is 3. 3 squared is 9. Plus negative 3 squared is 9. So we have right here, this is equal to square root of 18. we'll go ahead and just leave it at that for now. Because I don't really need to, I just need to know, are some of these sides the same or are they all different? Right? So we could just leave it at square root of 18. You don't really need to um, simplify it any further using your calculator. Although if you want, you're more than welcome to. So next up, let's find side AC then. Okay, so we got AC, and that is equal to, let's go ahead and put 2 minus 9 quantity squared plus 2 minus 3 quantity squared. Alright, so this is negative 7 squared is 49 plus negative 1 squared. So we got ourselves the square root of 49, which ends up equaling 7. So actually, sorry, square root of 50. We do have that 7 squared is 49, but then we have the 1 squared, or negative 1 squared, which turns into 1. So square root of 50. So I know right now that what we do not have is an equilateral triangle. So lastly, let's take a look at side BC right here. And then we have, or actually, what I found right here was BC. Sorry. So this was BC. And then let's go ahead and find AC this time. And so I can go ahead and put 6 minus 2 quantity squared plus 6 minus 2 quantity squared. So we got 4 squared plus 4 squared. So 4 squared is 16. This ends up being square root of 32. There's A to C. So I know none of the sides are congruent. So what I figure out for now is that we have ourselves a scalene triangle, right? Now how do I know, how do I classify it by its angles? Well, what I really care about here is this. You could probably, if you want, maybe draw a simple sketch. But we also, if I want to figure out right here if it's a right triangle, then that means we have a 90-degree angle. And if it's a 90-degree angle, that means I have two sides that connect that are perpendicular. So one of the things that I could figure out is that if we have sections or lines that are perpendicular, we should know something about their slope. And their slope should be negative reciprocals, right? So let's go ahead and try that out right now. Let's find the slope. I've got right here, we could have A to B, the slope of that. Let's go ahead and say 6 minus 3, and then take 6 minus 9. Remember, y2 minus y1 is equal to x2 minus x1. So right there, for A to B, we have a slope of, looks like negative 1. Okay, so there's our slope for A to B. For A to C, okay, let's go ahead and find the slope for that. We have 6 minus 2 over 6 minus 2. That right there has a slope of 1. Well, guess what? If I look at AB and AC, and right here, the slopes are negative reciprocal of each other, then that means that I know that we have ourselves a right angle. Okay, right? Look at the slopes. Slopes are negative reciprocal. So that tells me we have ourselves a right triangle. So what do we have? We've got a right triangle. So by its sides, it's scalene. When classified by its angles, it is a right triangle. So if I can't figure out if it's a right triangle, then once again, probably plotting the points would be able to help you figure out whether we have ourselves an obtuse or an acute triangle. Let's move on. Let's take a look next up at number 5. So we have find the measure of the exterior angle. Guess what? There is an exterior angle theorem right here. It says this exterior angle, which is number 1, is equal to the two non-adjacent angles right there. So if I were to set up my equation, angle 1 is equal to 53 plus 53. So angle 1 is equal to 106 degrees. Just that simple. Let's see if you can do the same with number 6. We have our exterior angle right here. 8x plus, or 8x minus 5. That right there is equal to the two non-adjacent angles, which is 40, plus, and then we have ourselves 5x plus 15. So go ahead and simplify this out so we can solve it. We got 8x minus 5 is equal to 5x plus 55. Right, I'll subtract 5x to both sides, and I get 3x over here. Let me add 5 to both sides, and 3x is equal to 60. Divide both sides by 3, and x is equal to 20. Now, that is x, but it's not our actual answer because they said find the measure of the exterior angle. So right here, the tricky thing is making sure at the end you take x, you plug it into the exterior angle, which is 8x minus 5, and solve it out. So 8 times 20 is 160 minus 5, that equals 155. And that right there is our actual answer. So be careful when you are looking at the problems, making sure that you solve things out correctly. Because solving this one correctly would mean to take the value of x and then plug that back into the equation so that you can find that exterior angle. Let's go take a look next up at number 7. It says in a right triangle, the measure of one acute angle is twice the sum of the measures of the other acute angle and 30. Alright, so what does all this mean? Okay, in a right triangle, the measure of one acute angle is twice the sum of the measure of the other acute angle. So I want you to think. Alright, if I have my triangle right here, it says one of the measures is twice the sum of the measure of the other one. Twice the measure, okay? That means 2 times the amount. Now it says 2 times the amount of what? The sum of one of the angles, and 30. So let's put it this way. Remember, these 2 angles right here is what we're talking about. The 2 acute angles, right? Remember, those 2 angles should equal 90 degrees. So let's think about, all right, we have one angle. And so let's put our equation together. And so one of the angles, let me call it x. If I were to add the second angle to it, which they gave us a lot of information, they said it's going to be the sum of the measures of the other angle and 30. So if I were to take the sum of the other angle, it's x plus 30. However, they tell us right here that it's going to be twice the sum of that. So I need to multiply this angle by 2. All of that is going to end up equaling 90 degrees. One acute angle plus the other acute angle is equal to 90. One angle we'll say is x. They didn't give us much information, but they said the other angle is x plus 30, or the sum of the measure acute angle and 30. And then we take twice that sum, and therefore, there's our setup. So now all we have to do is go ahead and simplify this out. So I got x plus 2x plus 60 is equal to 90. We've got 3x plus 60 is equal to 90. We'll subtract 60 to both sides, so 3x is equal to 60. And divide both sides by 3, x is equal to, oh, I don't know what the heck I'm doing right there. I've got myself 3x is equal to 30. And then x, divide both sides by 3, and x is equal to 10. So now the last thing is this. Find the measure of each acute angle. Well, if I plug in 10 into this one, that's one of the angles. So one of the angles is going to be 10 degrees. The other happens to be, well, plugging it in right here, 10 plus 30 is 40, times 2 is 80. And those are your two angles. And it all makes sense because remember, these two angles need to add up to 90 degrees. And 8 plus 10 plus 80 is equal to 90. So here we go. We started off figuring out what our different triangles should look like by its angle, by its size, and then also figuring out what some of those angles are. There you have 5.1.